Welcome everyone. Today we are breaking down SARS-CoV-2. As a medical professional, we know it as a beta coronavirus. So it's best described as a sophisticated thief, an intruder that doesn't just break in but hijacks the entire security infrastructure of the host. So here in the left panel, here you could see this viral cross section. SARS-CoV-2 is an enveloped pleomorphic virus containing a large non-segmented positive ssRNA genome. So it has a nucleocapsid, an envelope and a spike protein. So proteins that stabilize the RNA is called as the nucleocapsid. Envelope and the membrane define the viral shape and assembly. Spike protein is the trimeric glycoprotein responsible for the host cell detachment. Think of the virus as the thief, the red spike proteins as the master keys. They aren't random, they are specifically forged to fit one very important lock on our building, that's our cell. Now see the priming section. Key virulence is driven by furin cleavage site and the high affinity binding of receptor binding domain. The virus targets angiotensin converting enzyme 2 found heavily in type 2 pneumocytes. The virus requires priming by host enzymes like TMPRSS2 or furin to unzip the S protein and allow membrane fusion. Even with a key, the thief might find a dead bolt. The TMPRSS2 in our body acts like bolt cutters that the thief tricks us into providing. We essentially help him snip the lock so his key can turn. Now look at the center insert. So here we see the replication process. Once the membranes fuse, the positive ssRNA is released into cytoplasm. It immediately utilizes the host ribosomes to create two large polyproteins. Viral RNA-dependent RNA polymerase creates subgenomic RNAs, and the assembly occurs in the ERGIC compartment. So ERGIC basically abbreviates into endoplasmic reticulum Golgi intermediate compartment. Once inside the building, the thief ignores the valuables, goes straight into the 3D printers, that's our ribosomes. He loads his own blueprints and starts mass manufacturing of thousands copies of his master keys and tools, turning our own factory against us. Now refer to the fourth panel, the healthy versus NSP1 content. So this is a battle of signaling. The virus uses NSP1 to degrade most mRNA and block the ribosomal entry channel. This prevents the cell from producing type 1 interference. Later, beta cells produce neutralizing antibodies to block the keys, or spikes, while CD8 plus T cells acts as an assassination squad for already infected cells. A normal building would press a panic button that is interferent to alert neighbors. The thief's first move is to cut the alarm wires, that is our NSP1. By the time the police, that's our T cells, arrive, the thief has already taken over several floors. Diagnosis, prevention and prophylaxis. RT-PCR is the golden standard detecting the blueprint, that's our RNA. Antigen tests detect the thief's code, N or S proteins. Prevention. Vaccines provide the body with wanted posters of the spike proteins so that the immune system recognizes the key before the thief arrives. Monoclonal antibodies acts as muffs placed over the thief's keys so that they cannot fit into the ACE locks. Now look into the far right panel, ARDS. Severe COVID-19 is often an immunopathological event. Overproduction of interleukin 6, TNF-alpha and interleukin 1. So this leads to the cytokine storm. Alveolar capillary membrane damage leads to fluid accumulation and gas exchange failure. We use antivirals as in Paxlovid and remdesivir to stop the 3D printers and steroids to calm the immune overreaction. So the commonest steroid used over here is dexamethasone. When the alarms are late, the SWAT team, that is our immune system, panics. They don't just enter the building, they use explosives and tear gas, that's cytokines. This collateral damage destroys the walls and floods the basement, that's our arts. Often we have to treat the patient by restraining the SWAT team using steroids to stop them from destroying the building while trying to catch the thief. So that's it for the session. Keep reading Apurva. Thank you.